In this problem, we're asked to determine the formula weight of a gas. The mass of the gas is given in the problem, so all we need to do is to find a way to determine how many moles of the gas there is. And for that, we simply use the ideal gas law. The ideal gas law, PV is equal to nRT, and we're going to solve for n. To solve for n, we divide each side by RT, so we have n is going to be equal to PV divided by RT. We go up to the statement of the question to get our values. We have volume, pressure, and temperature. However, since this is an ideal gas law question, we want to make sure we express our temperature in Kelvin. We substitute in our values. We can check our units. We see atmospheres cancels, liters cancel, moles survives, and finally the units of Kelvin cancels. So we've set up our problem correctly. We can get a numerical value for the number of moles of gas. We do our math to get the value of moles of gas. We carry a couple extra sig figs because we'd never round until the end. We go back up to the statement of the question. We're trying to determine formula weight. It's grams per mole. We've just calculated moles. We have a couple extra sig figs. And we go up to the statement of the problem, and we can remind ourselves what the mass of this gas is. And here we have our final numerical answer. In terms of sig figs, we go back and look at the numbers that go into our calculation. We have 3 sig figs, 4, 3. Now here, be careful. You may be tempted to think we only have 2 sig figs in our final answer, but 63 degrees is not the number we use in our calculation. When we convert 63 degrees to 336 K, this number has 3 sig figs, and that's the actual number we use in our calculation. So in our final answer, we do appropriately use 3 sig figs.